Good morning, everybody, and welcome back to Next Door NetAdmin. Servers! What is a server? It's a common question, I suppose, from people who aren't usually working in the networking industry. So, since I'm about to talk all about servers, let me quickly give a brief introduction to what a server is in case somebody's listening who doesn't already know. You can think of a server as a really powerful version, I suppose you could say, of a desktop computer. Desktop computers typically have some limits that servers have much higher limits on. For example, a desktop computer might have quad core, 8 core, somewhere in between there, and then have hyperthreading as pretty standard on the lowest models and the highest models, and somehow not in the middle so much. Servers can have a lot more cores. It's very uncommon to see anything with less than 8 cores. And 16 or 12, 16, 20, 24 cores, even up to 32 cores is not unheard of per CPU. And servers may have one CPU, they may have 2 CPUs, they may have 4 CPUs, all working at the same time. Memory limits are also, generally speaking, a lot higher. A desktop, at least in my experience, the desktops that I've looked at, will typically max out around 64 gigs of RAM. And a lot of desktops will have, 8 or 16 gigs of RAM, and that's all most people will need unless you're into some really serious gaming or some other, very media heavy work such as rendering or art or heavy, really heavy duty gaming. Servers, on the other hand, will have gigs and gigs and gigs and gigs of memory for days. The maximum could be something like 1.5 terabytes of RAM or higher, depending on what you need. So servers are just essentially really powerful computers that have a lot more resources than a standard desktop computer does. Beyond that, they function mostly the same. There's a few things that servers don't do as well as desktops, primarily things like graphics, because you're not going to get a big chonky old graphics card into a thin 1U server. It's just not a thing that's going to happen. You can get that in bigger servers, but that's a different case of its own, and we'll cover that in a little bit. I have a customer that needs to replace 3 servers in a failover cluster. So this gives me the perfect opportunity to talk about what kind of servers I look for what purposes, and walk you guys through the process of going through all the hardware step by step and actually selecting, I want this, and I want this. But of course, as is often the case with me, I went through it and then I looked at the time and I went, that took me, 40 minutes? 45 minutes? So this is going to end up being another 2-parter because it's too much material to go through all in one sitting. Your mind will completely blank out, and I get that. So today, let's just talk about some of the basics of servers and how they're constructed. I've already explained briefly, in a very generalistic fashion, what a server is. I have used servers from several different manufacturers. The most common brand we spec is Dell. So I'm going to go into a little bit of detail on the tiers, the general ranking of Dell servers, just to give you a little bit of a feel for it. And then we'll move on to some other topics that are not Dell specific. They apply to all servers, and that'll be useful for everybody, no matter what model of server you get. So, but starting with Dell servers. Like I said, servers can come with 1 CPU, 2 CPUs, or 4 CPUs all working together. For Dell, the server line is called PowerEdge. There's 2 general types of servers. You can have a tower server. Looks a lot like a desktop, sits on the floor. It's a great girt big thing. Pretty tall, wide, heavy. Yeah. Tower servers are somewhat common in small businesses, particularly in small businesses that don't have any sort of dedicated network infrastructure. So that's a thing that's out there. But a lot of our customers do have some networking infrastructure. If you have a switch, if you have I was going to say enterprise class router, but that's not always the case either these days. Some routers can come in a standard form factor, same as a switch would do. Some of them don't. And some of them, you can get tricky and go, hey, this is a little thing that's designed to sit on a desk. I'm going to get an adapter that puts it into a standard 19-inch rack. That's always fun. But yeah, I just mentioned a standard 19-inch rack. There are racks. They are about 6 feet tall. They go from the floor 6 feet up. Obviously, if it's 6 feet tall, duh. They're about 19 inches wide. The gap in between the posts is 19 inches wide. You can have a 2-post rack. You can have a 4-post rack, which gives you more load-bearing capacity. But it's very common to see a switch, especially if you're dealing with 24 ports or 48 ports or more, to have it sized to fit into this rack. Racks are also measured in terms of U's or units. If you took a look at the video that I posted a little bit ago with a new OpenSense server that I got, that was a 1U server. Just about, 1.5 inches, I think is the equivalent. I don't know, honestly. But a standard 6-foot rack, floor to ceiling, is 42 U's. So you can get a half rack at 24 or 20 U's. You can get a little 12U jobby to mount on the wall or whatever you want. The racks come in all sizes. Not all shapes, but all sizes. And so you can have a server that is a 1U server. You can have a server that is a 2U server. You can have a server that is 4U's. A 4U server is sometimes convertible because a tower server is often the same width as 4U's would be in height. So you can take a 4U server and stand it on end, and you'll actually have it convert into a tower server. Sometimes. Not always. Just sometimes. In the PowerEdge family, then, you have these 2 types of servers, generally speaking. You have your tower servers. You have your rack-mounted servers. Tower servers are prefixed by a T. Rack-mounted servers are prefixed with an R. In the rack-mounted servers, specifically, also in the tower servers to some degree, but tower servers are something that I don't have to deal with as much as rack servers. But generally speaking, in the model number, the first digit gives you a general feel for where it is in the ranking, for lack of a better word, on the tiers for Dell servers. Something like a 2 or a 3 is entry level. It's not sized for hugely demanding tasks. It is sized for a lighter workload. If you go all the way up to an 8 or a 9, that is an extremely heavy workload. Most of the servers that I spec will be somewhere in the 4 to 7 range in terms of what the tiers are. And this has changed quite a bit over the years. It used to be that you could get a 200 series, 300 series, 400 series, 500 series, all the way up through all the numbers. These days, at least from what I'm seeing currently, Dell has, there's a 250, which is what I got for the OpenSense server. There's, in the new 16th generation, it's the 300 series, and then you've got the 600s, 700s, 8 and 9s. There are some model numbers that are 4 digits instead of 3. I think those are all AMD, so I don't know entirely how to interpret them. I haven't worked with them as much. The second digit, I just mentioned, 16th generation. The second digit of the model number will tell you what generation the server is. Plus 10. So when it's an R250, okay, you know it's an entry-level server because it's a 200 series. The second number being 5 means it's 15th generation. And if I'm speccing an R660, it's a 600 series server that is the high end of mid-tier. And then the 6 means a 16th generation, which is brand new at this point. The last digit, for a 3-digit server number anyway, if it's 0, it is an Intel processor. If it is a 5, it is an AMD processor. That's just how Dell has decided to work their model numbers. And again, there are 4-digit model numbers, but I'm pretty sure they all end in 5. That's why I'm pretty sure they're all AMD servers, and I'm not sure what the 4th digit is for in the third place. So, okay. I'd have to research that and get back to you. There's also some additional letters following some of these models. And that is something that took me a little bit of time to understand what they were, because I'm like, okay, what's the difference between a 760XA versus a 760 versus a 760XS versus a 760XD2? What is this? So let's break this down for you. Dell actually has documentation on this, and I will put the links in the description so that you can check it out and read more on it later if you want. The XA model, starting with that, and I'm going to just generalize for a second here and say that the X should be thought of as extra in all of these cases, but then the second letter will tell you a little bit more about what it's extra at. For XA, you can think of this as either extra AI or extra acceleration. And in this case, we're talking about GPU acceleration. The XA variants are designed to hold more graphics cards and be able to handle more of those GPU-heavy loads, such as machine learning, AI, rendering, etc. Then they have the standard variant with no letters. This is just supposed to be about flexibility. It can do a lot of things. It doesn't focus in any one area. It's a generalist. Okay. XS is extra scalable. You could also think of it as extra small, but I think that does the XS models a bit of a disservice. They're not small. They're focused on scalability because this is what is designed for a lot of virtualization. Virtualization workloads tend to require a different balance of CPU to memory in terms of ratio. So for scalable workloads where you're dealing with stuff that is very heavily virtualized, the XS line is probably your way to go. Then you have the XD2 line. There used to just be an XD, but now it's XD2. Okay, inflation, I guess. And in this case, you can think of it as extra density or extra disk. The XD models are very, very, very heavily storage focused. They might have 24 drives in front and another 24 drives behind in an extra fold-out shelf in the middle of the server. Lots of disks. I would not spec an XD server. I would rather probably spec a NAS, but they make it available and there's no denying it can handle the extra disk load. So, okay, fine. That's a thing that they have. Cool. So, when you're selecting a server for a particular client or for a particular use case, it's very important that you know what is the server intended to be used for, because that is going to determine what tier are we looking at. Are we looking for just a little web server or a router? Or are we looking for something that can handle 10 virtual machines and needs boatloads of RAM and CPU and everything else? Is it going to be virtualization heavy? Is it going to be needing to run real-time databases, in which case the standard model might have the flexibility that you're looking for? Are we going to be using any sort of graphics acceleration? Do we need an XA variant? So the exact model that you're looking for is going to depend very heavily on what you want to do with it. Now, other details as we go through this. CPUs. Your CPUs are going to require possibly a little extra looking up, because you'll often just get a list of, here's a bunch of model numbers of CPU, and you go, well, what makes this different than any of these other ones? Okay, so if you open up Google, Google being your friend, if you type in Intel Arc, as in ARK, and then look up the model number, you will get the Intel Arc page for that. The Arc is their archive of all of their CPU specs, and it can be a very useful thing to look at, because you'll get details on what advanced features the CPU supports, how much memory it can handle, of what type it can handle, at what speed it can handle it. And a lot of this, if you're going through a product selector, at least for Dell, Lenovo never really had one of these that worked in the way that Dell's did. I'll detour for just a second here. Lenovo servers, certainly when I was speccing Lenovo servers, were just order a chassis and then order a bunch of parts, and it's up to you to determine whether those parts work together or not. This was arduous. This was very arduous. There were multiple times when I ordered the RAID card I wanted, only to find out that I had ordered it in the wrong form factor and it wouldn't fit in the server. Fine. It's a way of doing it. Everything was off the shelf. Okay, fine. Dell's server builder is a lot more integrated, and they will custom build the server to the specs that you put in. And I'll show you that next week. But it's still important sometimes to be able to know that, yes, this CPU can do this level of performance, even though Dell's server builder is a lot more integrated, and it, in most cases, will not let you spec something that cannot be assembled. And one of the points that you can look up on the Arc for these CPUs is memory. And this is important because one of your next crucial points to consider is how much RAM you're going to put in and in what quantities. RAM will come in sticks of 8 gig, 16 gig, 32 gig, 64 gig sticks. And you need to sort out how many sticks you're going to give each CPU. Now, rule number 1, very important, each CPU must have the same amount of RAM. This is just the way that things are. It is a requirement. It doesn't work if you provision the CPUs with different amounts of RAM. It just doesn't. So if you have a 1 CPU server, obviously you don't need to worry about this, but if you have a 2 CPU server or a 4 CPU server, you need to make sure that what you decide to put in the server can be evenly split between the CPUs, or else it's not going to work. You also need to consider memory interleaving. What is this? Well, it's not something that even most of the people that I work with are aware of, generally speaking. Memory interleaving is a technology that is used in pretty much all CPUs at the moment, that I can tell anyway. which in order to speed up memory access, if you say, hey, I want everything from 1 to 20, it'll split this up. You say, here's a contiguous area of memory, and you'll say, okay, 1 will go to memory stick A, 2 will go to memory stick B, 3 will go to memory stick C, and then when I say I want everything from here, it can pull from multiple RAM chips simultaneously, rather than having to wait for one chip to provide all the data, and this speeds it up. If you're going to make memory interleaving work successfully, you need the CPU to be able to say, I'm addressing all of these channels all at once. Channels is a word you may have heard before, because that is something that we have seen in desktop PCs. Dual channel or even tri-channel systems. And then you can get RAM for your gaming system that is in packs of 2 for a dual channel system. Or when tri-channel was a thing, you could get them in packs of 3. And it was designed so that you would have 1 stick per channel. And then sometimes you could get a second set if you had 4 slots total or 6 slots total, and each channel would have a maximum of 2 slots available to it. Servers work pretty much the same way, but there are a lot more channels to consider. For the current Intel Xeon processor line, which is what you find in servers, first and second generation had lesser number of memory channels available. I think for the second generation it was 6 memory channels available. Starting with the third generation, and we're now on the 5th generation, it's 8 memory channels per CPU. And each channel has 2 slots. So each CPU can take up to 16 sticks of RAM at like 64 gigs each. So you can fill these servers with boatloads of RAM if you have the money for it and if you have the need for it. Not many of my customers do, but that's okay. The capability's there in the hardware. But memory interleaving means that there are particular configurations which are better for the CPU than others. If you have a CPU that has 8 memory channels and you fill 3 of them, that's not good. It has to work with a disjointed number of channels, meaning it's going to try and address 3 channels and then have to skip over 5. It's just not as performant. So there are some guidelines for how many sticks of RAM you want to have for each CPU. A balanced configuration is the best, and that means that you have all memory controllers working with the same amount of RAM per CPU. That means if you have 8 memory channels and you have 2 slots per memory channel, that means that for a balanced configuration, you want either 8 or 16 sticks of RAM per CPU, and that is optimal. 8 sticks of RAM per CPU gives you the highest performance. 16 sticks of RAM gives you very good performance, but the greatest capacity. Okay, pretty basic. Then you can have near balanced configurations. A near balanced configuration is nearly balanced. You basically go with starting at half of your memory controllers are full, and you can have half or 3/4 of the memory controllers full, because then it's got at least 50% of the controllers with something, and you actually want to space it out and use the slots in such a way that it can evenly go, use one, skip one, use one, skip one, use one, skip one. That's easy to mask off. Or, use 3, skip 1, use 3, skip 1. Something to that effect. These more complex configurations, Dell has already done the slot numbering on their motherboards so that you can just fill them basically from 1 to 4, and it'll take care of that for you. It'll skip the ones that it's supposed to skip, and it'll fill the ones that it's supposed to fill. But for a near balanced configuration, you need 4 or 6 or 12 or 14 sticks of RAM. So for optimal, 8 or 16. For nearly optimal, 4 or 6, 12 or 14. 2 is not on there. 10 is not on there. Neither are any odd-numbered configurations like 7 sticks of RAM per CPU. That is going to hang the CPU up pretty badly. It'll run. Don't get me wrong. It will run. But it will not run well. So when you're sizing the amount of RAM you need in a server, it's not just about how do I actually get a number of sticks of RAM to do this. You could say, I want a 64 gig stick and a 32 gig stick, and that's 96 gigs of RAM. Okay, cool. But even in a 1U server, that's not going to be optimal because that's only 2 sticks of RAM and your CPU has 8 memory channels available. So you need to break it down further and go, okay, so if I want 96 gigs of RAM, I can do this as 6 sticks of 16 gigabytes, and that's a nearly balanced configuration. That is optimal. You could also do it as 12 8-gig sticks, but, you know, that depending on what ranking it was and all the rest, there's lots of other details to consider on RAM alone, plus all the other bits and pieces. But this gives you an idea of some of the things that a system administrator or a network administrator has to keep in mind when they're building a server. And this is true for all servers that run everything. Amazon runs on web servers. Office 365 runs on web servers. eBay runs on web servers. Databases that Walmart uses to track products moving around, they all run on servers too. The government runs on servers. Big business runs on servers. Nonprofits run on servers. Everything computerized runs on servers. And so building these requires a decent amount of knowledge. Anybody can build something and have it work after a fashion. But if you want it to run well, there's a lot more to dig into. This video has gone on long enough as I've prattled on, but for now, this just gives you insight into the basics. Next week, I will actually open up the system builder for Dell server using the Dell partner website, because that has a lot more options than the standard consumer version of their website. And so we'll be able to see all of the hardware options that you can specify so that you get a good idea of what it looks like when you're actually building this server. But that's for next week. So for now, I hope that you found that interesting. I am your next door net admin. Thanks for joining me.